1. Okay, you're live.
Okay. Ladies and gentlemen, once again, ladies and gentlemen, good morning, good afternoon, good evening, wherever you are. Hopefully you are healthy. And I'm Dr. Atif Farid Mohammad. I would be sharing a pragmatic data science learning. And let me see if I can share my screen with you all. So let's begin this thing. And I will take this screen away. And so kindly just in your window share that you can see the screen. Hi Manav, how are you? It's good to see you. Hey Joe, good to see everybody. I am happy to be back. Thank you to our wonderful management team of Data Science Conference. Amelia Martin specific, who happens to be a wonderful friend and a leader in the industry. So I'm Dr. Atif Farid Mohammad. I would be conducting the session of potentially 1.5 hours, and if I go over, Amelia will send me a note or send me a text. So here is, let's go with the real live details in pragmatic machine learning. Who I am a chief scientist at OnRiva. It's a corporate travel marketplace. I'm also an adjunct artificial intelligence professor and machine learning professor at the University of North Carolina at Charlotte. And we will be looking at pragmatic machine learning together. Let me go further. So the index that is going to be for this workshop technically starts from data acquisition. And you might ask, I have not asked you the requirements. I have not asked you the problem. Well, the thing is this: if I have no data, it doesn't matter if I know your problem or if I know your requirements. I need to have some data, whether it is created data, it's dumb data, it's real data, it's streaming data, or it's any data. Then I need to do data pre-processing to do the feature extrapolation. There is a feature extraction, and then there is a feature extrapolation, two different things. We'll discuss that in a little bit more details. Then we walk into, hi Yuri, hey well, then we walk into data exploration and preparation, and from there we'll go into feature engineering, model selection, model evaluation, and future predictions. Future predictions can happen as we know from using standard y is equal to mx plus c, or that is a standard regression line, or we can use forecasting methods such as time series or forecast in terms of weighted time series, so we can find out what is going to happen with us tomorrow, day after tomorrow, or in the future. The data acquisition and pre-processing is a whole gigantic task in its own. In this phase, we do capture, maintain, and process. So let's take an example of airlines flying in from any given destination. So they need to first take off to touch down. So how do we know that the flight has been taken off from Chicago and is about to reach Detroit? If the flight has not taken off for any given reason, then it doesn't matter what is the reaching time, and that can only be predicted once the flight takes off, because we know the destination mileage from Chicago to Detroit, or perhaps New York to San Francisco. So that's a very, very base understanding that we establish. We need to know the data sources, and on the premise, on premises or versus cloud, there are two distinct data sources we can have now at one time. We can have on the prem, and that is Hadoop, whether we are using Cloudera, Hortonworks, which is now a part of Cloudera, or MapR, which is now the part of Hewlett Packard. But we are still utilizing the Hadoop, good old Hadoop, for the big data utilization for our machine learning or any artificial intelligence needs. The pipeline, the streaming versus batch processing, low versus high frequency, What are we working with? Are we working with the Olympics advertisement analysis? How many people were tuned in? How many people actually tuned out when the ad started? So what are their geographical locations? Why the ad is not popular among older generation than the younger generation, Gen Z, Gen X, Gen Y? The environment, we have to have an on-premises environment or cloud environment. It depends whether we are dealing with the regular data sets, which is small, which can be, still available within the databases like SQL Server, Oracle, or MySQL, or DB2, and that's not considered usually the big data or the humongous data. That's where we start jumping into data lakes, and that data lake is the next destination from the data warehouse, where we apply standard data mining. In data lake, we use machine learning and data sciences. Wrangling and exploration of the data, structured versus unstructured, and that you might say, okay, why structured or unstructured? So let me give you an example. The structured data is a database data where we know this is first name, middle name, last name, address, zip code. Unstructured data, one big line came with comma separated or comma delimited. Then in that case, what we are going to do, how we are going to work when we don't know the metadata, we just have the data sets with us. So let's go into look into the first stage of data pre-processing. So I'm going to show you some steps here. If you look into the left, you will actually, yes, the SQL or MongoDB or Cassandra is one of the good examples. Thank you sharing, Joe. So let's look into that. The customer ID, gender, senior citizen, partner, dependents, tenure, and all that jazz is a whole sequence of metadata. Here I would like to embody three major philosophical things that you must know when you're walking into machine learning or artificial intelligence domain, that you must know the narrative. A narrative is a storyline which you look as an outsider and you do not input any bias of yours in that. You do not have a say in that. The narrative is a whole storyline that comes to you where you have not even changed a dot in it. You have not added anything in it. You just have got the major chunk of the storyline and then you go with it. But then the second step comes, and that is the ethnography. Ethnography is you start making means. Okay, this is a man, this is a woman, this is an aeroplane, this is the airport, this is a building which is considered as an airport. To your health. And then if you see at this specific data set, it says customer ID, gender, senior citizen. So how the heck we know this is a senior citizen? If we are just given the date of birth, the year of birth, we can figure out by just putting up very simple formulae, mathematical formulae, that we subtracted from the year 2021, we get the age, whether the person is over 65, is a senior citizen or not, and that can be filled in automatically. So if you see, there are two things, one is blue, one is red. That is no and yes. These are two labels. No, I'm not going to do it. Yes, tell me more about it. I would like to have this phone service. No, I will not like to have this phone service. Usually what happens if you are with Verizon and you're with AT&T, then you have to make a call when an AT&T person stops you and asks you which phone service you have. You say Verizon, and then they start giving you all the details. Then you have only two answers. Yes, move me over to AT&T, or no, I would like to stay with Verizon. Again, it is no definite order that I'm sharing. It's just saying yes or no. I would like to go on the cruise liner. Yes or no? If no, why not? If yes, then what else I would be liking on the cruise liner? If I'm traveling in an airplane, will I like one hop or will I like a straight flight? I will make a choice. These are the choices we make as a human, same choices. So what we do in machine learning using Python, so this is going to be a Python-centric workshop. We import relevant libraries. Like you can see on the left side is pandas.core.frame.dataframe. This file came into Pandas frame, and Pandas is a library. I'm not going to go into the details. There's plethora of information available on the Google and on the Learn Python sites where you can find what Pandas does for you. Then we import the data set, evaluate the data structure, check target variable distribution, clean the data set, and check for missing data. What is clean the data set? There might be gibberish data that is coming in. There might be data that is for the sleeping generation, anyone over 85 years old. Would you be selling them the cell phone? The answer is yes. I mean, they deserve a cell phone. But usually, they are not the people who are marketed directly as a marketing effort. You have to work hard. They are the loyal most audience you can get if you're going to sell them the cell phone service. So let's see how it goes in the next. So data exploration and preparation. This is the second stage. In this, we have to find the types of variables, what type of data, that's numerical data, that's characters data, that alphanumeric data, that's yes or no, or true or false data, that's data with some numbers, the variable category. So we decide what categories we are going to work with. Is this a yes or no answer that we are going to predict? Or is this going to be several cruise liners we are going to predict with several of the perks that come up with their cruise line facilities that they provide us? Whether they need the COVID test or they don't need the COVID test. Again, this is just in no given order. This is just a discussion for the sake of understanding. Missing values handling. There are times when we get the data where there are tons of missing values and we have to fill in with a dump value, and dump value comes in with the previous value and the next value and see what can be the best fit. And then we actually flag that data. So we are not going to utilize that for prediction or prescription. Outlier detection. That's another thing. So if you are a person who has the utmost respect for authority or authenticity, then you might be an outlier making a call for your family. Authority and authenticity comes for your individual self when you have been marketed something. Everyone is treated equal when they are marketed with different visions of selling a product. So in that case, everyone, all of those external stakeholders where the salespeople are reaching out, giving independent and individual packaging to make them feel authority and authentic decision making. So that's more of a personal connection that these salespeople make with you. They are the successful people. If the salespeople treat you equally with the other person X or other person Y, then it's not that effective. It's not that very personal. So that is a statistical outlier discussion. Anyone who treats you with respect, obviously you earn respect when you give respect. So that's where you feel more authentic when you're making a decision. Machine learning, any machine learning scientist, data scientist, or artificial intelligence science person or research person is there to facilitate you, to assist you, not to make a decision for you. And the last one is variable transformation. So variable transformation happens that it does not matter which generation you are, they should give you an appropriate choice to make a call, whether it's a prescriptive call or it's a predictive call. The next is ML modeling. And in this process or in this phase, we do analyze and communicate. Feature engineering is comprises the transform, binning, temporal, text, image, feature selection. So if I'm going to sell you, for example, if my company sells corporate travel market and I want to sell you the airline ticketing, but I also offer you a car rental and I also offer you a hotel, then I must be giving you a decent package for you to make a call when you go and do a compare and contrast with Expedia, with Travelocity, with Priceline, or with somebody else. So because even at delta.com or at americanair.com or at united.com, you find all these offers available with their partners. So then you have to make a call. So the individual organization that is reaching you has to make sure that they are transforming their information and they're appropriately binning it for your temporal time set. You might be living in Eastern time frame. The company is reaching you from Pacific time frame. And then they have to convince you that your next trip should be from New York to San Diego or Los Angeles. Reasons given, these are the potential upcoming attractions post-pandemic era. Then you can visit the Universal Studios in LA, for example. And then if you opt these packages, you will be getting the best seats. You will be getting the best seats on the buses, travel buses, which will take you to the Universal Studios. And in that example, we do the model training, and that's where we apply algorithms, ensemble, parameter tuning, retraining, model management. When I say model management, I can give you a standard time series for forecasting. I can give you a weighted time series for a little bit more accurate potential forecasting. And obviously, when I do forecasting, I have to look at seasonal trend. I have to look at cyclical trend. I have to look at irrational trend. And then when I look at all these trends, obviously COVID-19 is an irrational trend which came back after 100 years time frame, which actually took the entire globe by hook or by crook. The idea is pre-pandemic, if we work from 2011, 2012, 2013, then we can predict 2014 potential because there is no pandemic in our hindsight. So the model evaluation happens where we do cross-validation. We check whether machine learning model A is better than machine learning model B. Which model we will be using? Either we are using the supervised learning or we are going to use the unsupervised learning. If we are going to use the supervised learning, whether we will be utilizing the classification technique. If we are going to utilize this classification technique, what it could be. Here's an example. I know most of you have a chance to know these characters in your time of life. I'll take a sip and then I'll continue. So the machine learning model design for classification can be understood as this one specific example. So this is a natural group among these. If I want to classify, then I can see there are men, there are women, there are children. But if I go and classify them using some sort of classification, then I can see a woman, man, a boy, a man, a woman, a man, a girl, and a man. So with my bare naked eyes, I can see there is an older man, there is a younger child, and there is a worker. There might be a school principal or administrator. There might be somebody who is, running outside, and there is a lady who's smoking for no given reason. If I look at that, then I can simply, with my previous knowledge, which I acquired with the pace of time as a human, I can see as a human that this is Simpson family. Computer will not be able to distinguish that. A machine learning model does not know what is this. They have to come up with the answer that, okay, what is this? And they will then scrape the internet for the information. Then I see, okay, this is a school family. This is a janitor. This is a principal. This is potentially a teacher, or this is somebody else who's administrator, but is doing some sort of stunt in the Halloween time, for example. If I go further, then I say there are females, and then I don't just give them a name, but I look at the males, and then when I go look at this, there are two types of clustering that kicks in. One is a hierarchical clustering. That means the teacher is connected with these two families, and they are in a school setting, and this is a hierarchical clustering. This is also understood as the decision tree. when we have a decision tree, we have nodes or edges. If I look at partitional clustering, then I have two partitions. One is a family partition, one is the school partition. So I can apply both hierarchical clustering or partitional clustering at the same time on the given data set. Let's look at more pragmatic way in the analysis utilization within the machine learning domain. So we can do exploratory analysis, confirmatory analysis, predictive, regression, text mining, qualitative analysis. So the idea of the analysis is we want to know whether the data that came to us has some qualitative arguments associated or quantitative numbers associated that we can actually predict or prescribe some sort of you know depiction of a future. Again, this is a narrative. And when we read it in a narrative, we convert that narrative into ethnography. Ethnography means we are now learning about the metadata. It's a man, it's a woman, it's a child. All right, this man is a principal, or this man is a father, or this man is a teacher, or this man is a janitor, or this man is somebody who has nothing to do with the school system, or this man is a superintendent of the district. Is this man the general manager? Is this other man is the retail clerk? So again, is this man the surgeon, or is this man the doctor, or is this man the administrative assistant, or is this man a practicing nurse, or is this man a chiropractor or a physiotherapist? One man can be all of those things. Or is this woman is the one who runs the media agency? Is this woman in the marketing capacity, she works there, or is she the CEO of the organization? If she is the underwriter of the mortgage. So you can imagine that a lady can be in all those roles. She can be a principal of school and then running the entirety. So there's the idea. The customer churn use case will be utilizing for our telephone company, and I have got the data from relevant resources. I have selected few categorical variables, and those are gender. It's a partner who's selling the plans, or it's a phone service which has been sold. Is a senior citizen being approached? Are dependents being approached? Are the families having multiple lines, or the no phone service? Are they also simultaneously hitting for internet service, online cybersecurity, online backup, device protection, tech support, streaming TV? So you can see I have done a partitional clustering among the results that I got when I applied some of my machine learning models in this specific arena. If I go further, so I can see the customer tenure. The customer tenure means that I had a chance for the people who were with me from 1 month to 60 months and more. And the number of the customers I had for the 1 month was 800, but then in the second month I had only 400. The third month I had 200. The fourth month I had this, and up to 20 months I had 170. I'm just giving you a rough estimation. And with the 60 months tenure, I had a chance to have 500 people who were with me, with my company, if I am, for example, Verizon or AT&T. So the tenure and the type of contract analysis. So month-to-month contract, how many people were there for 72 months? 1 year contract, how many people were there for 72 months? And then 2-year contract, that when I offer a 2-year contract with reduced prices, how many people were there with me at that time? So you can see significant difference between month to month and a 2-year contract, because the prices were better, the features were better, the facilities were better, the rewards were better, the loyalty rewards were better. The churn analysis can also be looked at the tenure and the churn. If you see in the first one, this is the analysis that is given in a way which is density-based analysis. If I look at the monthly charges, other than the tenure. If I look at the total charges, then I can see the first churn and the last churn is pretty much similar, other than the last churn total charges were more heavier on the side of people churning less. When the tenure was, the standard tenure was monthly charges, then we can see that there was more no's than there were yeses to join in this typical use case. If I look at the churn analysis in a little bit different visual analytics way, so the churn is no, means they stayed, yes, they moved out. For example, they're Comcast or Spectrum, or since I live in Midwest, so we have different altogether services here. So if you see on the from top left to top bottom, you see that the trend is depicting a huge difference between people who left and between people who stayed. So you might say that there are two different depictions given in this, but again, with matplotlib, you can depict in either or way. But if you see that the line graph is better than the plotted dot graph, because in this line graph we have a shaded region which is permitting us to look at, to make a decision on a better note. So that's why I actually brought in two different graphs here for you to see. The next churn analysis is with tenure and the contract type. You can see the distinct results in terms of 1 year contract, month-to-month contract, and 2 years contract. There were people who said they will stay, blue, and one, they will not stay, they will leave. The balanced trend is in a 2 year contract. And then when people look at seriously look at a family plan, they definitely look at a 2 years contract, because then they have to stay and they want to keep their bill, usually billing smaller rather than larger month-to-month basis. All right, let's move on. So if you see that overall churn in months is huge, but when you see the churn analysis in a little different way, the senior citizens versus the younger audience. The senior citizens said no, they will stay. The younger audience said, well, we would like to walk away. Reason behind the loyalty understanding is different in the senior citizens, is different in the Gen X, Gen Y, Gen Z, and like that. So every individual generation which raised up, they raised up in different atmosphere with different strategies that they learned, and the youngest most generation at this moment, because I have two young kids, 16 and 12, so I can understand that it's more of right now, like Amazon Prime Now, for example. That's one of the examples. However, it's okay to wait for 2 days or 3 days for the delivery of some sort of product. In the third stage, we conduct the feature engineering, and that's where we do feature extraction. That refers to feature selection, can be based on statistical significance, using a scoring mechanism to determine the best features. Feature extrapolation defines new features through inference by extracting known information. So we find statistical outliers. We find the variance among the data sets. We find the variation of our services, that when we offered, what results we saw for our potential clientele. Feature selection, the two schools of thoughts. The one is the upper arrow, that is the green, that why even think about feature selection in machine learning? The information about the target class is inherent in the variables. Naive theoretical view. More feature means more information, more discrimination power. This is not discrimination in terms of the human understanding. It's discrimination between the features. Shall we take age? Shall we take the year of birth? Shall we take the zip code? And if we take the zip code, then what is the potential? Are there malls near? Is Walmart or Target near? Lowe's or Home Depot near in that with that neighborhood? So that allows you to determine, you predetermine that what sort of audience is there for you to sell something or provide the services. Feature selection in machine learning, the answer is yes. Many explored domains have hundreds of tens of thousands of variables. I remember when I was at Comcast, there was 1,486 variables for the people who were tuning in for World Cup, for World Cup football, and the World Cup soccer, and then there were programming that was going on for the prime time, for the children programming, for the news programming, because Comcast owns MSNBC and all that jazz. So you can imagine that there are so many features which were associated with one single program. Who's watching, who's skipping, who's changing the channel, because when we press anything on the remote, that's called set-top box click change. So the click stream analysis is absolutely implementable in that situation. What exact time of the instance customer changed the channel, and what was the program that was going on? It's good. Chai latte. Irrelevant and redundant features can confuse learners. Limited training data, limited computational resources, the curse of dimensionality. So usually people avoid to do SVM, support vector machine reason. That goes in extremely dense in extremely dense computation. So if we introduce new features in our phone services, XYZ phone services, then how many services we are adding? And if we are adding more services, whether we are getting an answer in no or yes. Acceptance of an app is usually when you launch an app, you market it. And whether you're using iPhone or Android, it's okay to use either or phone, but is one app provider giving only iPhone app or also giving the Android app? The latest example is there's an app called Clubhouse. And there are two Clubhouses you will find when you will go on your Google Store or iPhone store. And then one is Clubhouse audio app. And when you look at that app, when you download that, it was only iPhone only app before, and it was on invite only app. So you could not even get in unless somebody could invite you. Then they opened it, the same facility for the Android users. And everybody jumped in who was at Android because they were waiting for that app to come in. Clubhouse is where you can form a club and people can come and talk to you audio only. There's no video, there's nothing else. Now they have brought in the back channel, which is chat, like pretty much like Instagram. So the idea is that Clubhouse is not a new app. Twitter has Twitter Spaces. The Spotify has Green Room. The Instagram is always there. Facebook is there. LinkedIn also, I think, provides such services which has front and back end available. I'm not sure about that. So you can look at the correlation analysis that I have created using the data set that I showed you in the very beginning. The churn, the payment method, the month to month, the online backup, yes or no, the streamlining TV, yes or no, online security, fiber optic, yes or no, and the list goes on. And you can see the tenure that came out of the list with correlation analysis when I put using my machine learning models. The 4 stages we now go into machine learning, and that is where these are a few steps that you have to be mindful of. Machine learning person is a facilitation person, is a facilitation team, is not a decision-making team. The decision makers are different people. The decision-making in software, usually the promise of machine learning for commerce marketing by Bronto, that humans make decisions and software assists. Software makes decisions, human expertise is not required. That is the artificial intelligence. That's Tesla. Or that's the blue capsule where William Shatner just went into space. A human is not technically involved. It's pretty much self-sustaining flight. Tesla, you can put it in autopilot, but usually, like if you put it in autopilot, would you be comfortable with it? That's my question. You might be, you might not be. Again, it depends. You are or you are not. So if we look at the Bronto's depiction, the rule-based decision making is human-oriented. Statistical reasoning is still permitting humans to make a call on the numbers. Machine learning, when you go into machine learning, then you take the expertise of machine learning algorithms designed by humans. But when you go into human-centric conversational skills like Lex, which is Alexa's backend, like Google Dialogflow, which is Google Home's backend, Microsoft's Skype had in 2017 all the transcribing services live when somebody was speaking. So you can imagine that these are all the services which are available in for us by all these organizations. So we split the data set into dependent and independent variables. That's the first thing, 0 and 1, the beginning. Generate training data sets, so 80-20 or 60-20-20, which is still 80-20. And when it says 60-20-20, then 60 is the main data set, 20 is your training data set, and next 20 is your actual next level of training data set to put MLOps, machine learning operations, and deploy of those machine learning algorithms. Then you do remove identifiers. So as we live in the United States or Canada or in Europe or UK, then we have to adhere with the GDPR, in California CCPA, in Canada PIPEDA, and all these privacy laws that we applied on us, like in the United States for healthcare, it's HIPAA. We need to be HIPAA compliant. We have to provide the security of an individual for PII, personal identifier, and PHI, personal health identifier, and all that jazz. And then you conduct feature scaling, whether the person who has been brought into the hospital has other comorbidities associated with him or her. It's congestive heart failure is the main reason, but behind that is their anxiety, stress, or depression, or any hypertension that we are unaware of. So we need history in ER before we start treating anyone in the emergency response. So then compare classification algorithms, whether KNN, the K nearest neighbors will work, or ANN will work, artificial neural networks will work. Which one is suited? Whether we should all abandon that and go with the naive Bayes, and that is pretty much the utilization of supervised learning, that we can start with naive Bayes where there are few of the information available and few we can go and extrapolate by applying the plausibility and probability. So visualize classification algorithms, accuracy comparisons, and then how accurate our results are on the basis of previous 3 years, 6 years, 9 years data sets. So if we have a 9 years data set, we can take first 3 years and then apply weighted forecasting, and we can forecast the 4th year. And then we take second, third, and this forecasted year as 3 years, and then we apply the weighted time series on it and apply the 5th year. So that's standard application of forecasting. Select which is the best model evaluation and deployment. That is where MLOps comes in, machine learning operations. Then model improvement, that goes post implementation support. So we go into the decision making at this time, that the storage charges were found to be the most important features, and rightfully so. The number one reason customers will churn if they find the service to be expensive or unaffordable. Now, I was sharing with you the details of narrative and ethnography. There is a third psychological narrative, the third psychological research sciences comes in, and that is called phenomenology. What is a phenomena associated to something, and how we can actually figure out as an outside standing individual, as an indirect stakeholder, to learn from that phenomena that is happening. The ethnography tells us that there is a churn happening. The narrative tells us the whole storyline that we are trying to sell this phone service with these feature X, Y, Z, A, B, C, LMN. However, we are still not being successful. So what is lacking? Where is the lack of approach we are having in terms of our decision making skills to supply the right approach to the people who accept our proposition rather than reject it? Acceptance and rejection, yes and no, 0 or 1, plays the main vital role in any decision making. The tenure was also found to be important. The customers who have been using the service for a longer time or have long time contracts, which are cheaper in general, are less likely to churn. So as I said, I'm stuck with Verizon, but Verizon allows me to utilize so many services at one time. The next is the most customers who are month-to-month contracts were found to be more likely to churn, and it can be hypothesized that reason is to be attributed to personal reasons of customers to have reservations about long-term contracts or higher costs per unit time resulting from monthly contracts. So these are the few decisions ahead that comes to our knowledge. If I look at Python for machine learning, then I will actually share with you that why Python? Why not R? Why not C#? Why not C++? Why not Golang? Why not Solidity? There are tons of programming languages available to us. Why Python? Python gives us plethora of libraries to work with. Python is REPL. Python is not structured. It's not object-oriented. Can we use it? Yes, we can. But we'll have to go and change our mindset when how we are going to utilize Python. So it provides functionality and packages for importing and cleaning the data, pandas, as you just saw in the very first example that I shared with you. That's a library that permits us to extrapolate and extract variables, the application of ethnography right after the narrative. If you know the storyline, you can create the ethnography, the metadata. And there are times when we deal with metadata of metadata, whether it's a human is a main class, it's a man or a woman, it's a boy or girl, it's teacher, it's principal, it's lawyer, it's a salesman, it's a manager, it's a driver, it's a pilot. It's still a human being. A pilot can be a woman or a man, right? Pilot can be anybody. The teacher can be anyone. So it depends who's teaching you. It's you who had made that decision to come and sit in that class. And then you are going to learn or unlearn few things. So Python allows us to perform quick operations on both dense and sparse matrix, as well as other mathematical operations such as Numpy, another library, SciPy is another library, and then built-in libraries for machine learning tasks such as Scikit-Learn, the visualization matplotlib. We can also use PyTorch and TensorFlow to conduct in-depth neural networks analysis. And then if I go further, the pandas allows the user to interface with data in many formats, like CSV files, like text files, places data in data frame object, easy to explore summary statistics. Basic data visualizations can be done using pandas. Showing data frames in Jupyter notebooks places data in familiar format. Interfaces seamlessly with most machine learning Python packages and the code that we write as a Python person. Here's another example. The pandas reading data set. So we simply do import pandas as PD. It's not police department, by the way. It's pandas for PD. So my DF, my data frame, pd.read underscore CSV test.text. Now somebody has sent me a big text file, the name is test, but I want to read it as a CSV. I don't want to just simply cat it. Like in assembly language, you used to write cat this file, whatever the file is, and then the whole dump comes on the screen. So in this case, when I do the output, when I put my underscore df and I press enter or run, I get column 1, column 2, column 3, column 4. These are assumed columns, 0, 1, 2, 3, and the data that was in the text file was 0, 1, 2, 3. In the first row, the second row has 4, 5, 6, 7. The second row is, or the third row technically, because in Python the counting starts from 0, 8, 9, 10, 11. You might understand that these are the sets, and this is the set membership. If you remember the good old set theory, we had unions, intersections, we had subsets, we had supersets, we have the universal sets, we had prime number sets, we had the 3, multiples of 3, multiples of 5, and all that jazz. So let's see. Excellent. So there are some notifications on my screen, and we are in 45 minutes. So let's go and speed it up so we can have some Q&A time available. So if I look at pandas obtaining summary statistics, the familiarity with the data is important in machine learning. Pandas make the first steps to process it simple. So if I say, okay, describe me whatever I have in terms of statistics. So it has given me the count of total, column 1, how many values are there. The mean, the standard deviation, the minimum value, the first quartile, the centroid, the next quartile or the last quartile, and the maximum. And these are the basic statistics that pandas allows us to look in. Let's look into NumPy. NumPy permits us to use arrays and metrics, and matrices and are ubiquitous in Python scripts. It provides us the functions of common matrix operations and linear algebra. Again, if I say, if we sell X number of tickets, we will have our revenue. What if the tickets are $5 per piece? You do the linear algebra for that, and you will know what it means. R is revenue is equal to 5x. 5 is the price of the ticket, and X is the number of tickets sold. And you will get the revenue. So provide, and that's linear algebraic equation, provides functions for common matrix operations and linear algebra, includes useful functions for sorting the other basic necessities. And if I look into a NumPy example, it is often represented in matrix form. So if I say import NumPy as NP, and I say A is equal to NP.matrix, and I give 1, 2, and 3, 4, and I have given a semicolon right in the middle to show how it will show me. When I press A, I find out that 1, 2, and 3, 4 are two distinct sets. When I do B, np.matrix 5, 6, 7, 8, then I have another distinct sets. Can I use them applying the standard additive property or a plus addition? Then I get the answer as you see in C. So let's go into the next screen. And that is, as said before, NumPy has many built-in functions for common matrix operations. So if I say A dot B for a D, which is D another variable, when I say print D or show me what the heck D is, then it shows me all the new results. If I apply the Lin algorithm or EIG on C, then that actually, so I'm not going to go into the details what a Lin algorithm is and what EIG or eigenvalue is. You have to look into that by yourself. And when I put that on C, then it gives me an array and a matrix in detail. So there are eigenvalues which are very intriguing. You should look into that when you're looking at machine learning. So there is a thing called eigenspheres. Javion is a healthcare company that has actually worked on eigenspheres in detail. JVION. I would suggest you to read those documentations so you understand how they are providing hospital at home services for you. So SciPy is similar to NumPy, and as shown below, the standard for sparse matrix. So here from SciPy, I am importing sparse. SciPy is a library where X is equal to sparse.csr matrix A and print X, then it gives me a whole different display. And if I go Y sparse CSR matrix B and then Z is equal to X plus Y, so I have utilized two things in one 9 column of, 9 of my line in Python, and that gives me two distinguished processing at one, and it prints Z for me to look into. So if I go Scikit-Learn, it's a library containing many common machine learning algorithms for supervised and unsupervised learning, small data sets for learning ML. There are pre-processing functions, built-in functionality for many common metrics, many other useful tools. Scikit-Learn is where we start actually writing our ML algorithms using Scikit-Learn library in more depth. Here is an example. Running models with Scikit-Learn is very simple, so we don't have to recreate the wheel. The wheels have been given. We just need the chassis so we can put 4 wheels and run with it without the engine. Can you do that? The answer is no. It's pretty logical. You cannot run a car without the engine, even if you have a chassis and the wheels and all the other things. So here is the engine. So when we use from scikit-learn.tree import decision tree classifier, now we are looking at something. Now we are cooking something. So I say classifier CLF, and I apply decision tree classifier where CLF.fit. Now I'm going to fit a training model of a training data set, X train and Y train. When I put up some predictions, I find out by printing the precision, the recall, the F1 score, and the support. I'm not going to go into details. The idea is that we did not have to rewrite all these things from scratch. Scikit-Learn is a very powerful tool, and it also gives you the accuracy of the results. So when you have the accuracy of 97%, 96%, 97%, weighted average is 97%. So you have now two comparisons available in F1 score, and you will utilize those results to make a decision. Another example of scikit-learn is regression. Regression is y is equal to mx plus c, as we know in our everyday life. I'm not going to do this in this, but you will have this video available, so you can literally type this code, and this will actually allow you to learn linear regression. I would strongly suggest to you to learn linear regression in the statistics before jumping into machine learning, because machine learning utilizes other variables and other classification algorithms before they jump into linear regression. For you to find a standard line, draw a line, a potential predictive line for you to make a decision or call. So machine learning in part based on model of brain cell interaction. The model was created in 1949 by Donald Hebb in a book titled The Organization of Behavior. The book presents Hebb's theories on neurons, excitement, and communication between the neurons. When I pick the cup up, now my hands know that the cup is there. When I take a sip, combination of picking the cup, taking a sip, my tongue has tasted something, chai latte. How I know that? Because of my previous experience. The neurons worked. The taste went and gave me an answer that this is a chai latte. So I would suggest you strongly to read this book if you can, when you get a chance, because that's where it started. So ML learning, here is the standard learning ops, ML ops. We can look at that. The supervised learning, classification, unsupervised learning, reinforcement learning, and deep learning. So when we are applying ML ops, we look into these 4 categories before we jump and make a decision. So supervised learning, let's look at supervised learning, where we learn an input and to output map. We are given some kind of an input. It could be a description of automobile comes, and look at the beautiful thing. I have found my own mistake and I'll correct it while on the go. Comes to the garage, and the output is that have to produce it, whether the vehicle has a certain spare part change required or just an oil change required. Again, that's a diagnosis that we know, because when a car comes into the garage, it's the It's the mechanic's job to make a call. You are not making a call. ML assists us with pattern recognition. Here are a few patterns. Patterns can be global, can be local. Global means clustering via partitioning, hierarchical clustering, as I just showed you in case of symptoms, and mixture models. Local can be outlier detection, who is drinking more chai latte in the home and who's not. So change point detection, bump hunting, scan statistics, and association rules mining. So data mining can be local pattern extraction for machine learning. And that comes from the data warehousing domain. The numbers, ML allows us to conduct analytics, what, why, when, where, who. The idea is we are in a situation where we must know all these 5 W's. What we need to do, why we need to do, when actually we need to do it, where should we do it, and who is going to benefit from that. So these are the main questions, and look at this list very carefully. There's nowhere how given. How it is done is not given in this list. So that's a distinction between machine learning and the regular learning outside. Machine learning deals with the functions. The big ideas is the candy in a machine where we can go and make a choice. F1 give me the Twix bar. F9 give me the Dr. Pepper. Or A2 give me the Lay's chips. That's a function. You are directing. Whereas on the second, there's no function. You have to put the quarter in. Something will come as random. That's erratic, irrational. So if I key in B14, I'll get the snack what I want. The answer is yes. That's a decision making. That's the empowerment of a user, of a decision maker, of a machine learning algorithm. Fraud detection is another area. Any transaction made with a lost credit card is fraudulent. How to identify such transactions? This is not the zip code of the person who usually buys a zip from 58201, Grand Forks, North Dakota. This credit card has been used in 28216, Charlotte, North Carolina. Stop it. Don't permit this transaction. However, there's a note comes in that the card user put up a note in advance. I'm traveling. I'll be in Charlotte, North Carolina, so I'll be using my card there. So don't stop it. The stop it or don't stop it is yes or no, 0 or 1 answer. How to identify such transaction? I just will give you an example. So this is a message for organizers. When I click the data science made real, the link goes to the Pragmatic machine learning session live stream. Well, that is the question that the organizers can answer you. So it is a classification problem. A transaction is either fraud or not fraud. So Raj, I would suggest you to send a note to Amelia or any other organizer. Another use case is fraud detection, feature extraction, or feature vector. Amount spent unusually high. Stop it. IP address, not the standard used every day. Stop it. Failed attempt. Stop it. Time since last transaction. Stop it. Location. Stop it. So bank can say stop it, stop it, stop it, stop it, all of those places. Unless you have advised, my location is changing. I'm going to use this card after 3 years. I did not use it previously. So don't stop it. Let it go. Variables associated with the problem. These are all random variables. There are 3 types of random variables: discrete, continuous, and categorical. Discrete starts from 0 and at all the integer values. Continuous is 0 to 1 or 0 to infinity or any real number. Categorical or group, red, blue, or green. High, low, middle, Midwest, Central, East Coast, West Coast. The problem is we cannot predict a transactional value until it happens. We can determine the range is yes. Amount spent will be between 0 and unknown number. This is still the credit card example. IP addresses will be any except which you use legally. Failed attempts could be any number. Location, Boston, Miami, etc. That's another classification use. So again, I discussed this in a little bit detail. Narrative is where you get the storyline and you stay outside and you do not have any bias of yours added into the storyline. Then you start evaluating ethnography. It's a man, it's a woman, it's a child, it's a car, it's a cart, it's a bullock, it's a cow, it's a goat, it's dog. And what they are doing, whatever is happening in that domain, is the phenomenology that you also look as an unbiased person. A phenomena changes t+1. When the next time hits, the phenomena can change. The person is eating in the morning and then eating in the afternoon and eating in the evening. The person is eating in the afternoon and eating in the evening. The person is eating in the morning and evening only. We are the only outside viewers or reviewers. We are not actually going to have a say as the machine learning people. This is ML philosophy. We will predict or prescribe. Grounded theory is scikit-learn, applying regression, applying forecasting, applying artificial neural networks, and all that jazz. So we are reaching almost the end. The narrative is an inquiry is a type of qualitative research that explores human experience through lived or told stories to understand a phenomenon. Narrative researchers collect data through spoken or written stories and life experiences of an individual subject. The data is looked through a chronological order to understand the meaning of a phenomenon being studied, described as discussed by Creswell. Creswell was a scientist who published in 2013 the choosing among 5 approaches, and it was Thousand Oaks, California. That's where it's published. So I would suggest you to read that. This is the philosophical domain for machine learning, and it starts from the Edmund Husserl in early 1900, which goes to Paul Sartre and Martin Heidegger. So these are the names that you must know because they were the mathematicians who brought in the machine learning even at that time. We were not aware of the name. Historical origins of narrative storytelling, rationale, constructionism, and making sense of something. Machine learning allows us to make sense in advance. Where are we heading to? The philosophical goal of this talk are that you understand that you are a facilitator when you're a machine learning scientist, machine learning engineer, or data scientist, or an artificial intelligence practitioner. You are a facilitator. You can predict, you can prescribe, you can do descriptive analytics, predictive analytics, prescriptive analytics, and decision analytics. However, you are not going to make a decision. The decision is made by someone who has a big wallet, who pays your bill, who pays your salary, and all that jazz. So with this, I thank you for your time, and I'm now open to questions because we are in our last stretch. So thank you again for being such a great audience of this 1,358 people. It is a very decent number. So now I'm open for your questions. There you go. Well, Justin, thank you. I love these tools. Yes, you are absolutely correct. Justin, we cannot survive with them if we are using R. Then we have R libraries, and those libraries are far enough. So that's a good idea. Joe, thank you for your time, for being here. I hope I had a chance to contribute something for yourself. Any questions, and every questions are welcome. So thank you for your time and excellent overview. Yes, you get. I'm glad that you're there, and you're all welcome to connect with me on the LinkedIn. And let me go and get you my LinkedIn. So you're welcome to be my partners in learning, because that's how I learn. I take cues and I go from there. Zach, thank you so much. Veronica, you are most welcome. I'm just waiting for my LinkedIn to respond so I can actually revert and get you the answers. Again, I am a real chief scientist of OnRiva and an AI professor in adjunct capacity at UNC Charlotte and Maryville University in St. Louis, Missouri, where we are trying to establish some AI domains for robotics these days. So you're welcome to ask me any question. Thank you, Manav. I'm glad that you got a chance to attend this. If you have any questions, you're most welcome to reach me via LinkedIn, or you're welcome to ask some questions here also. And meanwhile, I'll enjoy my chai latte. So, ladies and gentlemen, in that case, if there are no questions, I would pay my farewell, and I hope to see you on my LinkedIn. And if there are any questions ever you need any help in terms of machine learning or artificial intelligence, you're welcome to connect with me, and you can reach me. Here is my LinkedIn that I'm going to share with you. So as a person who is not in computer science, would you recommend the books for learning the basics of NLP? Yes. I would suggest you to read the book by Edmund Husserl, Logical Investigations, to start with, and Martin Heidegger's book of Being There. That's your grassroots learning. And then from there, you can go and learn the application of natural language processing in Google Dialogflow. That is the best so far I have seen. I have not done much research in Amazon Lex or Alexa, but you can absolutely learn natural language processing utilizing the basic learning. So O'Reilly Books is one medium where you can find some of these decent books. So let me take a chance to ask one question. Yes, Manav, how far do you think we are in the, we are from AGI? The idea is, yes, Zach, thank you. I will actually go ahead and link that for you. Thank you, Data Science Connect host. So we are reaching the artificial intelligence at a level where we have now Sophia Henson as a robot. We have Tesla. We have Boston Robotics. So you can look into that. We are just at the edge to find a person in front of us, more likely be a non-human robot in few years time frame. So hopefully that answered you. Well, in the case if there are no other questions, I would render the mic back to the host. If the host has any questions, I would be glad to answer.